Today we cover sections 6.1 and 6.2. I have good news about section 6.1 and 6.2. What's the good news? It's probably the easiest two sections in the whole book. That's the good news. Alright, so section 6.1, we're going to learn about polynomials, and we're going to learn about adding and subtracting them. What's a monomial? Anybody know what a monomial is? It only has one term. Okay, so what's a term? A term could be a number, or it could be a number and a variable, but special things have to happen to the variable. Can the variables have powers? Yes. They can have powers, but they can only have certain kinds of powers. No, they can't have negative powers. They could be even. They don't have to be even. It could be 3x cubed, for example, would be okay. Okay. So a monomial is a number or a number times variables with counting number exponents. So what are counting number exponents again? What are counting numbers? 1, 2, 3, 4. It could be past 10. 1, 2, 3, 4, 5, 6, going on forever. Those are the counting numbers. All right, so some examples. Here are some things that are monomials. 8. A monomial can be just a number. That would be a monomial. 8. 16x to the fourth. That has a number times x to a power, and the power is a counting number. 4 is a counting number, so that's a monomial. What else would be a monomial? How about this? Is this a monomial? 1/3 x. Okay, 1/3 is not a counting number, that's true. But where do the counting numbers have to be? The exponents. What's the exponent on the variable here? It's a 1. So the exponent is a counting number, so that's okay. So a monomial can be any number times a variable, as long as the variable has a counting number exponent. So I think that one's okay. The exponent, we wouldn't normally write it. The exponent is a 1. How about negative 6xy cubed? Is that a monomial? Okay, notice I wrote in my definition, or a number times variables. Is it okay to have more than one variable? Yes. Yes, it is. So that was a tricky question. I threw 2 variables in there to try to trick you. It usually works. So this is still considered a monomial. You can have more than one variable as long as you're multiplying things together and all the powers are counting numbers. That's okay. All right, so here are some things that are not monomials. Can you give me some examples of things that would not be monomials? Six plus x. Very good. That is not a monomial. Why not? Because it's not multiplying, it's adding. That has another name, though. That one's called a binomial because it has a monomial plus a monomial. So that one does have a name. It's called a binomial. But it is not a monomial. That was the correct answer.
So, 2x exponent 1/3.
2x to the 1/3 would not be a monomial. Excellent. Because the exponent is not a counting number. That is not a monomial. Very good. So you cannot have powers that are fractions. Okay, what else? Any other non-monomials? 7y to the negative fifth. What's wrong with that one? The exponent again is not a counting number. Okay, and then one more. 4 over x squared would not be a monomial. What's wrong with 4 over x squared? I'm dividing, I'm not multiplying. The rule said I had to multiply. Or the other answer would be, I could rewrite this. That's the same as 4x to the negative 2. Because when things are on bottom, they had negative exponents. So that would not be a monomial for 2 reasons. You could either say you're dividing, not multiplying, that's no good. Or you could say you really have a negative exponent. Alright, so those are monomials. So what's a polynomial? It has many terms, and the terms are added and subtracted. So this is any sum and or difference of monomials. So for example, x plus 6. We already had that one as not a monomial. It was not a monomial. It is a polynomial. In fact, it's called a special kind of polynomial. That's called a binomial. Why is that one called a binomial? Because it has 2 terms. 3x squared minus 5x plus 8. That's a polynomial. What would you call that one? If you graph that one, you would get a parabola. That's true. More specifically, we would call that a trinomial. Why would you call it trinomial? Because it's a polynomial with 3 terms. Some other special words you should know. Coefficients. Anybody know what coefficients are? It's a number before a variable, correct? Conversely, we have something called constant. What's the constant? Number that doesn't have a number that doesn't have a variable. That's called the constant. So the coefficients, if I go back up here, what are the coefficients in 3x squared minus 5x plus 8? The coefficients are 3 and negative 5. They're the ones that are next to variables. And what would the constant be? 8 is the one without the variable. The number without a variable. Degree. Anybody know what degree of a polynomial means? Nope. Nope, it's not how many terms. How many terms determines if we call it a monomial, a binomial, a trinomial. What would the next one be? Monomial, binomial, trinomial? Quadnomial, I guess. What's the next one? Pentanomial. The truth is, after trinomial, I've never really heard them called that. People just call them a polynomial with 4 terms, a polynomial with 5 terms. But you could call them a quadnomial, a pentanomial. Degree. Degree is the biggest power. That's all degree is. So you look at your polynomial, you look at your biggest power. That's correct. So for 3x squared minus 5x plus 8, what would the degree be? 2. For x plus 6, the degree would be 1. That's the biggest power. And the last important word is leading coefficient. This is the coefficient of the term with the highest power. We won't really deal with this in this class, but the degree and the leading coefficient, those have a lot to do with the shape of the graph of the functions. We won't be doing much with graphs of polynomial functions in this class. Do it a lot in the next one. All right, so I'm just going to write down a polynomial here. How about 4x plus 6x cubed minus 9 plus 8x squared. There's the polynomial. First off, you should not be very happy with the way I wrote that polynomial. What's wrong with the way I wrote it? I didn't put it in order. That's correct. And what do you mean by order? What goes first? So the 6x cubed should come first. That's correct. And what should come next? 8x squared, and then the 4x, and finally the minus 9. So usually when we write polynomials, we write them in standard form. And standard form is you put the one with the biggest power first, and then you have the powers go down and they get smaller. So we really should rewrite that polynomial that way. That's the standard form for writing it. All right, and then I might ask you, what are the coefficients? Six, 8, and 4. What's the constant? Negative 9. Watch your minus sign. There's a negative 9. Okay, then I might ask you, what's the degree? The biggest power is 3. And finally, I might ask you, what's the leading coefficient? And you would tell me 6. Why is 6 the leading coefficient? Because that's the number, the 6, is the coefficient that went with the x cubed, and the x cubed was the one with the biggest power. Questions on that? All right, now we're ready to add and subtract polynomials. How do you add two polynomials? How do you take 2x squared plus 3x plus 5 and add 4x squared minus 6x plus 7? What do you mean by add the variables together? So I put the 2x squared together with the 4x squared? Not yet. Okay, this plus sign, this parenthesis really isn't doing anything, is it? If I distribute the plus sign through, it's not going to change anything. Those parentheses were really kind of wasted. Just add them how?
Slide the 4x squared minus 6x minus 7 over under the 2x squared.
Okay, so what you're telling me is you learned to add polynomials, what we call vertically. So you're telling me take the 2x squared plus 3x plus 5 and slide under it the 6x squared, or the 4x squared minus 6x minus 7.
Yep.
It does matter. We'll talk about that in just a second. This is one of the common ways to add polynomials. Add them vertically. So what do you get when you add them vertically? What's 2x squared plus 4x squared?
6x squared.
The powers don't change? It's not 6x to the 4th?
No.
How come the powers don't change? What's that? I'm not multiplying, I'm just adding. If I had 2 apples and 4 apples, you would tell me it's 6 apples, not 6 apples squared or something, right? The apples don't change. 2 things plus 4 things is 6 things, so that's 6x squared. What's 3x minus 6x? Minus 3x, and what's 5 minus 7? Negative 2. That's perfectly acceptable. Really, what we did is this. Those parentheses that I wrote really are completely useless in this problem. They're really completely unneeded because we're adding. When we're adding, does it matter how you put the parentheses? No, that's called there's a name for that. When you're adding, you can put the parentheses any way you want. Not the distributive property. One of those other two. Which one allows you to change parentheses when you're adding? Not the commutative. It's the associative. The associative property says as long as you're adding, you can put the brackets anywhere you want. In this case, we can get rid of all the brackets. And then really what we're doing is we're using the commutative property to do this. We're switching the order around. And that's what we do when we write it vertically. We really switch the order around. What's the rule of addition that allows me to switch the order around? What's the rule that says 5 plus 2 is the same as 2 plus 5? It's not the distributive. It's not the associative. It's the only one left. It's the commutative property. The commutative property says you can switch order around when you're adding as long as you want, as much as you want. So really what we do is we group what are called the common terms. What makes terms common? Same variables and same exponents. That's what makes them common. So we switch things around so that we have all the common terms put together. And then we can combine our common terms. 2x squared and 4x squared still makes 6x squared. Oops. This one's going to be minus 3x minus 2. So when you take these two polynomials and you line them up vertically, that's really what you're doing. What you're doing is you're using the associative property and the commutative property.
Like if you said it was a different way, like multiplying, would it be harder to do it vertically? Do you suggest that it's okay that we do it vertically?
It's okay that you do it vertically. We'll talk about multiplying in a minute. That's section 6.2. And you can either do it what we call horizontally or you can do it vertically, depending on which way you prefer. We'll look at it both ways. Okay, so here's what I expect in reality. If I were to give you 8x cubed minus 6x squared plus 5, and then asked you to add 4x squared minus 9x plus 8. The truth is, I would hope you could do this without really showing me any work at all. I would kind of hope you could just do this in your head. What would you do? You look for all the x cubes. Where are all the x cubes? The only one of them. So you write that one down, 8x cubed. Then you look for the x squareds. What do you have for x squareds? Negative 6 and positive 4 makes? Negative 2 x squared. Then you look for the x pieces. Minus 9x. And finally, the constants. Plus 13. And that's as much work as I would really expect you to show. Not too difficult. Now, I am going to make a suggestion. If I ask you to subtract polynomials, let's say we have 7x squared minus 3x minus 2 minus 4x squared minus 5x plus 3, I would highly recommend that you do show a little work here. What I would highly recommend you do is rewrite this as 7x squared minus 3x minus 2 minus 4x squared plus 5x minus 3. What did I do? I distributed the negative sign through. I highly recommend you distribute the minus sign through and you write that down. How come?
Because the negatives, you end up adding negatives.
Correct. What I find happens if people do not take the time to distribute that minus sign through and write it down, they screw up their minus sign somewhere. They end up adding when they should subtract or subtracting when they should add. So I highly recommend you do that. It only takes a second to write it down. Write it down again and then combine all your like terms. So we would write, what's our answer? 3x squared plus 2x minus 5. Questions on that one? All right, so that's adding and subtracting polynomials. So far, did I lie to you? Is this the easiest thing we've done so far? I think so far. How about multiply polynomials? This is really section 6.2 here. How do I multiply two monomials? If I asked you to take 5x cubed and multiply it by 2x to the fourth, what would you tell me the answer is? 10x to the seventh. Why 10x to the seventh? You multiply the coefficients. 5 times 2 is 10. And you add the variables. This is what we did in chapter 4. If you have x cubed times x to the fourth, you add those exponents. Okay. How about if I give you a monomial, like 3x squared, and ask you to multiply by a polynomial, like 4x squared minus 2x plus 6. You distribute it. That's exactly correct. You distribute it. Through the whole thing. That's right, because the whole thing is inside the parentheses. So what's 3x squared times 4x squared? 12x to the fourth. What's 3x squared times negative 2x? Negative 6x cubed. And finally, 3x squared times 6. 18x squared. So multiplying a monomial by a polynomial is pretty easy. It's just a distributive property. All right, how do you multiply a polynomial by a polynomial? What if I gave you 4x plus 3 and asked you to multiply by 2x minus 9? FOIL, okay, or the box method. There's a couple different ways to do it. Some people like FOIL, some people like the box method. What does FOIL mean? You're going to distribute, and FOIL tells you a specific order to do it in. So what does FOIL stand for? First, outer, inner, last. First, outer, inner, last is what FOIL stands for. So what that means is multiply the first two things. In this case, the first two things would be 4x and 2x. You multiply 4x and 2x, you get 8x squared. What does O stand for? What are the outer things? The 4x and the minus 9. That's the O. What's 4x times minus 9? Negative 36x. I stands for inner. What are the inner things? There's a 3 and the 2x, which makes 6x. And finally, last is the 3 and the negative 9. 3 times negative 9 is negative 27. No, I would not. I would do what you thought we should do. And what were you saying we should do? Add the two things with the x's. That's right. Once you do FOIL, once you do your multiplying, you look to add any common terms. And we do have two common terms here, negative 36x. So our final answer would be 8x squared minus 30x minus 27. Absolutely, you would combine your like terms. Questions on that? Okay, how's the box method work? Somebody mentioned the box method.
Oh, so we draw a box.
You draw a box.
And put lines in. Then 4x is on like the top, and then plus 3 is on the top right.
So I put
4x.
4x right there?
Yeah. And then plus 3. Then on this side, you put 2x, and then minus 9. And then you go 2 times 4 is 8x, right? 2 times 3 is 6x. And then negative 9 times 4 is 36x.
Negative 36.
Yes. And then 27.
Negative 27. And then it's the same sort of deal. You look for your common terms and you put them together. So your answer would be 8x squared. 6x and negative 36x makes negative 30x minus 27. That works very well too.
So it's FOIL with a box.
It's FOIL with a box. That's right. The box just kind of helps you organize your information. Helps you make sure you do all the things with all the other things. Or, so your third choice, so this, doing it the FOIL method, this is what's typically called multiplying horizontally, because you go across horizontally. This is known as the box method. The third choice is you can multiply vertically. So how does that work when you multiply vertically? Well, it works a lot like when you multiply numbers. How do you take 14 and multiply it by 26? You do the 6 times the 4. And then you do the 6 times the 1 and then add the 2, right? So that's going to be 8. And then you take the 2 times the 4, but you leave a space, don't you? So an 8 goes there, and then a 2. Then you add 364. Same thing happens here. You take the minus 9 and multiply it by the 3. What's minus 9 times 3? Negative 27. You take the minus 9, multiply it by the 4x. Negative 36x. You take the 2x, multiply it by the 3. 6x, but you leave a space, just like you did over here. So you put the 6x there. And then the 2x times the 4x. 8x squared. And then you add. So you get 8x squared minus 30x minus 27. So there's the 3 different common ways that I see people multiply polynomials. Some people like to do it horizontally. Some people like the box method. Some people like to do it vertically. Which way is the best way? They're all the best way. The best way is whichever way works the best for you. Do I care which way you do it? No, not at all. Personally, horizontally was the way I was taught, so horizontally is the way I almost always do it. Just the way I first learned. So if I was asked to take, say, 3x squared minus 2x plus 5 and multiply by 4x minus 9, personally I would do it horizontally. Now this one really isn't FOIL. How come this one isn't FOIL? Because I've got, yes, it's uneven. I've got 3 of them here, but only 2 of them here. But the same idea works. If you look at what FOIL did is it told you to take the 4x, multiply by the 2x, take the 4x, multiply by the negative 9. Basically, it tells you take the 4x and distribute it through. Same thing works here. We take the 3x squared and we distribute it to all the pieces. And then I'm going to take the negative 2x, and what am I going to do with the negative 2x? I'm going to distribute it to all the pieces. And finally, I take the 5 and I distribute it to all the pieces. That's really what the FOIL method tells you to do. This one's just going to get pretty long, but again, it's not difficult. 3x squared times 4x is 12x to the third. Minus 3x squared times 9 is negative 27x squared. Now I move to the negative 2x. Negative 2x times 4x is negative 8x squared. And negative 2x times negative 9 is positive 18x. And finally I move down to the 5. 5 times 4x is 20x. 5 times negative 9 is negative 45. Combine like terms. I think my final answer is going to be 12x cubed minus 35x squared plus 38x minus 45. Questions on that? All right, here's my last question. 3x minus 7 times 2x plus 5. Almost every student I've ever taught has at some point seen FOIL. Do you have to do things in that order? Do you have to go first, outside, inside, last? No, why not? What's that? Whichever way I start with, I'll still get the same answer. How come? Because it's multiplication. Can I change order when I multiply? Sure I can. Multiplication is commutative. So for example, I could decide to do 3x times 5 first. What's 3x times 5? 15x. And then I'm going to do the negative 7 times the 2x. Negative 14x. And then I'll do the 3x times the 2x. Plus 6x squared. And then which one's left? Which one haven't I done yet? Negative 7 times 5, that's negative 35. Did I get the right answer? Yeah, but what do I have to do? I gotta put it in the right order and simplify. So this should be 6x squared plus x minus 35. So if the order that you multiply doesn't matter and you get the right answer anyway, why does every book and every teacher in the world teach FOIL? It makes it easier. What does it make easier? First off, it does two things. FOIL spells a word. It's easy to remember. OILF doesn't spell anything, does it? Harder to remember. FOIL spells a word. It's easy to remember. And then, notice the nice thing about doing FOIL. I'll do this one doing FOIL now. We would have 6x squared plus 15x minus 14x minus 35. What makes doing it the FOIL way easier? It puts it in the right order, doesn't it? And these two terms that need to be combined, they're sitting right next to each other. So I think that's why people teach FOIL. It's just easy to remember, and it puts things in the right order. Makes it easier to simplify when you're all done. We would still have 6x squared plus x minus 35. Anybody have any questions about adding polynomials, subtracting polynomials, or multiplying polynomials? Did I lie to you when I said I think this is the easiest two sections in the whole book? No, I don't think so. I think this is among the easiest stuff we'll do all semester.